This lesson will teach me to use ratios and proportions to solve problems. Definitions. A ratio is a comparison of two quantities by division. Ratios can be written in several ways. We can use the fraction bar as A over B. We can use a colon, or we can use the word to as in saying A to B. Some things to keep in mind. B cannot be 0. If it were, it would be undefined. And we always need to make sure that ratios are in their simplest form. An extended ratio compares 3 or more numbers. For an extended ratio, we generally use the colon. A fraction bar would not be appropriate because fraction bars only compare 2 numbers. A proportion compares 2 equal ratios. An example, saying that fraction A over B is the same as fraction C over D, or think about this fraction. For instance, 5/10 is the same as 1/2. That is a proportion. When you set up proportions, especially for a diagram, there are very often several different ways you can choose. For instance, look at the small diagram. We can talk about 6 over x, and it would be set equal to 12 over y. Notice I went from the small to the tall, or from the, I guess you could call it flat to tall, flat to tall. Somebody else might say, well, can't we reverse it? Sure, we could go x over 6 is the same thing as y over 12, as long as you're consistent in your pattern. Another proportion might be going across 6 to 12, then we would have to go x to y. Similarly, we could go the other way and say 12 over 6 is the same as y over x. How can you determine if fractions are equivalent? Look at the diagonals if proportions are equivalent. In every proportion I wrote, notice the diagonal, the 6 times the y, was on the diagonal. And look at the other. The 12 and the x were on the diagonal in every other way. So there are several different correct ways to set up a proportion. How can you tell if the proportions are equivalent? We look at the diagonals. When we talk about now setting up, let's see, next question, I got ahead of myself. It says find the indicated dimensions. It says the amount of fencing needed for a rectangular yard is 280 meters. So what we're talking about here when it says the amount of fencing, is essentially perimeter. It says the ratio of the width to the length is 3/4. So think about this particular rectangular fence here. It's saying that the ratio of the length, so whatever the length is, over whatever the width is. If you take the length and put it over the width, whatever these numbers are, they will reduce to the fraction of 3/4. So I'm not trying to tell you that your length is 3 and your width is 4. I'm trying to tell you that if you compare the length to the width, you'll get the fraction 3 over 4. So we know that this has to be some multiple of 3, and this has to be some multiple of 4, so that if I were to put 3x over 4x, I would get 3/4. Thinking about perimeter is when you add up all the sides. So this length is 3x as well. This is 4x, because in a rectangle, the opposite sides are always the same. So in a perimeter, we add everything up. I have the two 3x sides, and I have the two 4x sides. And it's set to equal 280. So that's 8 and 6, so 12x equals 280. So x ends up equaling 18 and 2/3. It's a fraction, but no big deal. But it's asking what is the length of the rectangle. I'm going to plug this back in. Hopefully I entered everything right in my calculator, but I got that the length was 56 meters, and I got that the width was 74 and 2/3 centimeters. So if you take the length and put it over the width, you should end up with the fraction of 3/4 to show that your length and width hold that stipulation. The next one says that the measures of the angles of a triangle are in a ratio of 6 to 1 to 5. So thinking about a triangle, it has 3 angles. It's saying that if we compare this angle and compare this angle and compare this angle, essentially the extended ratio, which is kind of like a fraction, can all be reduced to 6 to 1 to 5. So this has 6 times a number, 1 times a number, and 5 times a number. So all of these have the same number in common. So if you were to take out that common number, you would compare 6 to 1 to 5. When you look at this triangle, the only thing we know are these 3 angles, but we know that triangles add up to 180 degrees. So I'm going to take the 6x, add it to the 5x, and add it to the 1x. So that's going to give me 12x equals 180. X ends up equaling 15. So when I plug this in, 6 times 15, and then 1 times 15, and 5 times 15, we have that this angle is 90 degrees, that this angle is 75 degrees, and this angle is 15 degrees. So the largest angle would be 90 degrees. And go ahead and check your ratio. That if you were to take out the number they have in common, which is that 15, you have a 6, a 5, and then a 1. Couple more. When you talk about solving proportions, I hope it's prior knowledge that we solve proportions by multiplying diagonally or cross multiplication. So when we multiply diagonally here, we're going to multiply 3 times 13, which is 39, and multiply diagonally across the other way as well. We get 4x. Now we have an equation. How do we get x by itself? Divide both sides by 4. Here, x is 9.75. Problem below is also a proportion, so we'll do cross multiplication or multiplying diagonally. 4 times 17 is 68. When we multiply diagonally the other way, it's not just 10 times x, but it's 10 times this entire quantity of x plus 6. So this turns into distribution. It's 10 times the x and 10 times the 6. And now we can go ahead and solve this equation. So 10x ends up equaling 8. Divide both sides by 10. X ends up equaling 0.8. Just to make a quick note before I go on, if you want to check your answers, if 9.75 is the answer, if you were to plug that back in and grab your calculator and divide it, it would equal the same number as this one. If you wanted to check your answer down here, if you plug in the 0.8, if you were to take 4 divided by 6.8, it would give you the exact same number as 10 divided by 17. All right, last question. It says Joe student transfers to AWHS in the middle of a semester. For the exam, I only assign him what he has been at AWHS to learn. The exam is worth 64 points, and with a modified exam, he earns a 37 out of 52. However, in the gradebook, the exam is entered out of 65. What score needs to be entered for Joe? If Joe's score was 37 out of 52, then I want to know what score needs to be entered out of 65. This is a proportion. We solve proportions by multiplying diagonally. 37 times 65 is this, equals, multiply the other way, 52x. How do you get x by itself? Divide both sides by 52. The score that would be entered for Joe would be a 46.25 because a 37 over 52 is a 71.153846%. And if I were to take this 46.25 and check this fraction, 46.25 divided by 65, I'm looking at the exact same decimal, 71.15 whatever percent. So our proportion is when two fractions are exactly equal. That concludes this video. Thank you. Please let me know if you have any questions.